Hello learners, welcome to Sure Question Academy. Please watch the videos, like and subscribe to the channel.
Hello again. Let's solve a practical problem based on the principle of moments for a first-order lever. We have a metal rod 1 meter long acting as a first-order lever. An effort of 150 gram weight at one end balances a load of 350 gram weight at the other end. Our goal is to find the exact lengths of the effort arm and the load arm. Let's begin by noting down the given measurements. The total length of the rod is 1 meter, which we can convert to 100 centimeters for easier calculation. The applied effort is 150 gram weight. And the load, L, is 350 gram weight. Since we don't know the exact lengths, let's assume the effort arm is x centimeters. Because the total length is 100, the remaining part, the load arm, will be 100 minus x. Now, using the principle of moments for a balanced lever, effort multiplied by effort arm equals load multiplied by load arm. That is, E times EA equals L times LA. Substituting our values, 150 times x is equal to 350 times the quantity 100 minus x. Expanding the right side, we keep 150x on the left and multiply 350 inside the bracket, giving us 35,000 minus 350x. Bringing all x terms to the left side, we get 150x plus 350x equals 35,000. Adding them up, 500x equals 35,000. So, x is equal to 35,000 divided by 500, which means x is 70. Since x was our effort arm, its length is 70 centimeters. And the load arm is 100 minus 70, which gives us exactly 30 centimeters. There we go. A perfect balance. Thank you for learning with me.